Hi, this is Merlin. I'm just gonna talk about Valorant today. So actually, I'm sorry, that the reason I take this video so late compared to the last video is because there's so many things to do instead of like studying about engineering thing, because I'm trying to start a business and I already had to like read some kind of like information about like business, like those kind of things. So that really led me to take this video, but this led me to procrastinate taking this video. But whatever. So today the main topic is it is about B3, because the reason why I keep some like take this video about B3 is really practical. Um, we know the data structure, like those kind of computer science algorithm data structure, the operating system, and the computer architecture. It's really kind of really the bunch of abstractions. We face problem, and that is really repeated, and we make it as some kind of theory, and that's kind of the history of computer science. So example, the B3 is so in terms of like putting some kind of out of the records. Example, you have you are you wanna store a lot of users data. There of course there are various users. Like example, there are 4 users. One, two, three, 4, and of course their information is gonna be different, of course, and also there should be like a little bit like the same values of it, but in fact that they are all different. So they might have the age, and also what else, the gender, what else, I don't know, but let's say age and gender, and birth. Yeah, birth's gonna be, and also there should be, I think the most important part is ID is just the unique value of this kind of information, because this is object, and this is also known as record, which is basic unit of data. So the users have the same record, and they have different unique ID. And to trying to like search, example, you wanna get this guy with the hat. So you have to know about some kind of ID, or some kind of age or gender. But the best way is using the ID, because you wanna select it. But the thing is that rather than traversing all of the users and goes to the some kind of like reading the age, gender, and birth and ID, we just make it this kind of way. Why don't we just extract the ID, the unique IDs per users? So there's gonna be bunch of IDs, and the ID is called the record key. So that's the key of the record, and we somehow think that the making as some kind of file, putting into bunch of record keys is gonna be more simple, rather than, because we don't have to traverse of this kind of the object values, right? So we just put it in here. So that's called the index. So index file is just the bunch of record keys, and that's very simple. But there's another problem that we faced. What if there are a lot of users, example 10,000 of users, and you don't want to get 90,000, the user have the ID 90,000. I mean, that's great, really great. That means you have a lot of users, but the thing is that you want to select the ID of that is the 90,000. That also means that you have to go to the 0 to the 90,000. So which is kind of not quite efficient, because that means you have to traverse to you encounter 90,000. So we face this kind of problem. If it's like 10,000, 100,000, that leads to the time. So what if, so we computer science, the engineers, we figure out, rather than putting it to some kind of linear way, let's say we build a tree data structure. The tree is basically, the binary tree is, let's say binary tree. The binary tree is basically, you have a node, example, let's say this is the node. And so of course the node, the 4 here is gonna be the record key value. You have 4, nice. And the 3 is gonna be go the left part of the 4, because the 3 value is smaller than the 4. And also if it is 5, the 5 goes next right to the 4, because the 5 is bigger than the 4. And this is really how to construct the binary tree. So if it's 6, go here. If it's 7, go here, and gonna be go here. But what if? So that's the best. The best way is have the max childrens. So the parent node can have the maximum 2 children. The binary tree, of course, the binary tree is gonna be here. But that's really simple, and that is kind of really good, because you don't have to. Because the more the depth of the tree to increase, the more of the time complexity gonna be increased. I mean, like, of course, you have, rather than traversing go here and go here, but rather than go like this, it's gonna be more issue about like go traversing. But the binary tree, the limitation about the binary tree is there's no kind of rule of which putting limitation on the height, or putting limitation of the minimum node of here. And also, what if they are the same node? What if we just want to put the 1 node and 3, the 1 key and 3 key in 1 node to increase the search? So that is the background of the binary tree. B tree comes from. So to construct the B tree is very simple. You just have to declare the max size of the node can have. So what I mean node can have, the keys, the max length of keys. For example, let's say 3. And also 3, 4. Let's say 3, 4, 5. Is gonna be here. 3, 4, 5 is gonna be here, and now you just have to insert the new value. It's just like simple. It's kind of really similar with the binary tree. If it's 2, go next to the 3. If it's like, let's say 1. If it is 0, of course you go left to the 1. But if it is 2, you go right to the 1. But the thing is that the 1 is actually smaller than 2, but also the 4 is also the 2 is also smaller than the 4. So you don't really point based on the 1. You make pointer between 1 and 4. And that's a real kind of characteristic of the B tree. There's no right and left of it. You just have some kind of between the characters of it. And also, we just forgot when we encounter that the node have maximum keys, you select the primary key, which is 4, the middle index of it, and you go upward. You make this 4 as a parent key, the parent node here. So parent node, we're gonna have this 4 key, and of course the irrigation is gonna reference the value of like this. So that is really this is really how you make some kind of B tree. The more keys node can have, the height of the B tree is gonna be short, and the search query gonna be increased. I mean, of course, the space complexity will be gonna be more increased. So that's kind of like really simplified description of the B tree. B tree is really used in nowadays like database indexing, or also there are modern data structure which is B plus D. We're just gonna talk about B3 first, but after that we're gonna go ahead of the B plus 3. So this is it. Have a nice day. See you next time. Bye bye.